Welcome to Marine Tech Talk, a podcast about how Teledyne Marine's innovative technologies are enabling scientific discoveries and commercial tasks in the world's oceans and waterways. In this episode of Teledyne's Marine Tech Talk, we talk with Pim Kuss, Senior Hydrographer and Product Manager for Instruments and Imaging at Teledyne Marine. We will discuss Teledyne Marine's cutting-edge acoustic imaging technology and multi-beam echosounder solutions, including the Teledyne RESON CBAT T51. Teledyne RESON, together with Teledyne Blueview and Teledyne Odom Hydrographic, make up the Teledyne Marine Acoustic Imaging Group. This group develops some of the world's most sophisticated sonar technology and offers the strongest collective product portfolio in the market for subsea acoustic imaging and multi-beam echosounder solutions. Now, here's the host of Marine Tech Talk, Rhonda Moniz.
Hey everyone, welcome to Marine Tech Talk. Thanks for joining us. I've got Pim Kuss on the line today. He's joining us for this episode of the podcast. And it's exciting because I'm kind of a sonar geek, and Pim is their sonar guy over at Teledyne. And so he's going to talk with us today about that line of technology. And so welcome, Pim. Thanks for being on Marine Tech Talk. And I guess I first want to ask you, just so we can give the listeners some information and the audience some information, could you tell us, what you do at Teledyne? And then I know you work with their sonar, but what your title is. And then if you could talk a little bit about the line of sonar products that you work with and maybe get into some of the applications.
Yeah, sure. So I am product manager at Teledyne for the single beam and multi-beam sonars. My background is hydrographic surveying, so it's quite interesting to work for a manufacturer who was very much, of course, about building equipment, and where I'm very much interested in how is this equipment being used by our users, and what do our users really want. Also, if you think about the future, what is would be a next product that need to look like, and those type of questions. And yeah, you're right. There are quite a few different multi-beams and that we have in our portfolio, and they range from very small ones that use on a very small craft to very big ones. They're kind of the size of the room that I'm sitting in right now, and you would use those on ocean-going vessels and going as deep as possible. So there's lots of different systems, and then also how they're being used, what type of applications. It's is a lot of different applications. It's always surprising to me what people come up with, how they want to use it. You got the standard seabed mapping stuff, but there's always one or two that come up with a crazy thought of mounting it on a seaplane, for example, or some strange configuration where it's looking up, so quite a large range of sonars applications. We have systems that you can use subsea. They go on ROVs, AUVs. We have systems that go on very small ASVs or USVs, as they're called, so small surface drones, and then everything in between.
Yeah, there's definitely so many different applications for sonar, and it's interesting because the technology is advancing in leaps and bounds, and I mean, I've been in the field using it for a number of different things. I used to train people on ROVs and in the sonars associated with whatever the system was, and I've worked in that area too. And I mean, it's amazing because I think about it and I think, God, we couldn't really do a lot without sonar. When you think about it, it's so far reaching, and I guess pun intended. There's so many things that it would be so difficult for us. It's really kind of our eyes, if you will, in a lot of situations, low visibility, or, being able to like do bathymetric surveys, things like that. Sonar is a real staple of everything that we do, as I mentioned. But how does it compare to land sonar, for example? What are some of the differences?
Yeah. That's quite interesting. I mean, for like when the way we do our work in terms of the maths is very much the same for land surveying, right? Often, it all revolves around measuring a beam or using a beam and an angle measurement. A range and an angle measurement. So that's very much the same, but the equipment is different, and that's simply because we cannot look underwater. We take our measurement, and we will never be able to know if our measurement was really correct. Whereas land surveying, you can measure distance to a wall, and you can see that wall, and you can walk up to it and feel it and make sure that wall is still there. And what we do is, we have to have faith in our equipment. We sense the seabed, but we will never know if that is really what it looked like. We just have to really have lots of faith in our equipment and our installation. And then another aspect that makes it very interesting is when I look at land surveying, when I take a measurement, I can take that measurement 1,000 times. Nothing's going to change because it's always a static measurement. Whereas with hydrography, we are on a platform, everything is moving. And then we're imaging through a medium that can change. We have sound speed changes, salinity changes, temperature changes. That all has effect to the measurements. So it's and those are the things that I find really interesting about hydrography and the effects to multibeam systems. And
so you mentioned your background a little bit. Can you talk a little bit more about your background and kind of what brought you to Teledyne?
Yeah, sure. I studied hydrography. I had no idea what to study as when I was a few years younger, and I heard about this thing called hydrography, and I heard that you could travel the world and do something with water, and that sounded good to me. So I ended up doing that, and I had no regrets really. I thought it was pretty cool. And after my studies, I was fortunate to work for some different companies, get some, different types of experience. I got to see pretty much all corners of the world. I got to work on research vessels that brought me as far up as the Arctic, which was pretty amazing. And then one day I was talking to somebody, and he suggested working for this company, which was then RESON, and now we are at Teledyne some years later. It's
cutting edge technology and cutting edge sonar. So you've got all the toys now.
Those are the perks. Yeah, I always work with the latest, greatest. So that's definitely interesting. Yeah.
So I know that the technology is changing, and what are some of the things that you're seeing in the field that they may be using the specifically sonar technology for more? Are you seeing it change in any way, or is it different? What are they using it for? I know, obviously, as we mentioned, that seafloor surveys and things are a big one, but have you seen any changes with the applications at all?
Yeah. It's quite interesting because you see the equipment being used for all different types of applications. And that also means that people with different experience levels start using it. So we see that there's a larger appetite to create models of the seabed. But at the same time, we don't see more people joining the industry that want to do surveying. And that means that we have less experienced people starting to use these really high technology pieces of equipment. So for us as a challenge then, and something that we really picked up on, is that we need to make these things much simpler. So we have this big group of people that are going to be using it, so that they don't need to be a super duper hydrographer. They need to collect data and ultimately get a deliverable that they can give to their client and say, here's your seabed map. And that's a process that started a few years ago, and we're certainly not there yet. I think our equipment has some features that make it very useful for novice users, but there are also definitely improvements, and that's definitely something that's on our minds when we think about how would we be surveying in the future. Things need to be simpler, so almost anybody can just take it and use it.
Yeah, the ease of use. And I mean, any technology takes some time and training, and you got to get used to using it. And I know, working as a trainer myself, it can be a challenge because sometimes the technology is a little bit difficult to work with, and can seem not straightforward. So yeah, making it easier to use is obviously hugely valuable.
Yeah, I think one thing also that makes it difficult, or for new people a lot of people that come into this industry, they just kind of find themselves one day on a boat behind a PC, and they're
Right.
collecting. There are not a lot of textbooks on this topic, and even if there would be, it's very much something that you have to experience in the field. You go in the field and you try to set up the system, and then something doesn't work, and you try to troubleshoot, and so it's very much, you just need to get exposure to it, and also with that in mind, that is frustrating. It's frustrating if
Right.
you're behind your PC on your boat and you can't get it right, or you come home, you have a date set and things don't match up. And we want to limit that as much as possible, but that also just shows how difficult it is. It's not just a matter of training, it's also like the equipment needs to be simpler so that there's just less training needed.
Yeah, user friendly, making it more user friendly. Yeah, absolutely. So with regard to the sonar line, how many systems are there, or what are some of the different types of systems that Teledyne has on the sonar side of things?
Yeah, so you could kind of divide it up in two groups. We have the seabed systems, which you could say is shallow water systems, and we have the hydro sweep systems, those would be deep water systems. And then within that, we have systems of their own, and it's very much based on, particularly for the deep water systems, based on frequency. So of course, the lower the frequency, the larger your depth range is. But it also means that your arrays get very big, so you'd only find really those big systems on really large ocean-going vessels. And then on the shallower side, the seabed side, we have three systems: the T20, the T50, the T51, and those you could divide up frequency-wise. They're very much the same, but it's very much in beam width that they are different. And then the beam width is very very important parameter, because that defines your positional uncertainty and how accurate you could resolve the seabed or a profile or an object or such. And then again, within that, we have then these systems could be used in a subsea, or they could be used on an ASV, or they could be used on a vessel. So we have some variants that can accommodate those different applications better. So it's quite a range of systems, absolutely. But we have them but it's like, it's also for the entry level user has it, or we have the really high end system for high precision engineering type works.
Right. And also, it's you mentioned it, or we had talked about it a little earlier. And it's you have some that might be less precise because you're looking at a larger area, and then narrow down and really very very precise. Like the CBAT series, which is very precise sonar systems. In using the CBAT, for example, what are some of the applications that your clients are using with that more ultra detailed system of sonar?
Yeah, sure. There are quite a few reasons why you'd want to have, that very high resolution. If you'd be installing small objects like pipelines or cables, they are very hard to detect because they're small in the first place, and they are circular, so they kind of tend to bounce energy or sound off, so they're very difficult to pick up. But we have our users would need to first of all detect those, and then also detect the seabed to understand the relationship of a pipe or a cable, how it lays on the seabed. That would definitely be part of the kind of the high engineering type work. We have users who do some infrastructure like breakwaters or key walls that they need to image, and those are quite challenging areas also because there's it's not a flat seabed. Measuring a flat seabed is quite straightforward, but having challenging topography, it can confuse detection systems because imagine you're sending sound out and the sound comes back from all kinds of angles, and it could be very difficult to pick up the right one. So we have systems that are very very well tuned for that. And then you have the users that, for example, like for dredging applications or such, where the dredging is tolerances are very tight, and if you make an error over a large area, that equates to a lot of dredge spoil. So you do want to make sure you have it right. So it's really, if you're not really in the field of sort of hydrographic surveying, you wouldn't realize how many applications there are that really need all these maps. People, when they think about maps, they think about maybe something like that on the back of my wall here. It's just like maybe a map for sailing, but anything that happens underwater, you'd need to have that imaged, and so you need a multi-beam of some degree to get that information. So there's a lot of different applications that we see.
And you worked you mentioned this too, just to kind of put it in perspective as well. So for, obviously when you need to be, you need to have more accuracy, you need to work in higher frequencies. That's for, as you mentioned, more of a shallower depth. What are the depth ranges for the higher end as far as more accurate systems? What are the depth ranges in there?
So if we look at our high resolution, our highest resolution sonar, which would be a T51, that runs at 800 kilohertz. That is a high frequency, and then the trade-off is your range performance. It really depends on what kind of swath width you want to have, because as you would go deeper, your range would go less, and then your swath becomes smaller. But we've done tests with it, and we could comfortably measure with a large swath up to about 30 to 35 meters, and after that you would need to start condensing your swath a bit. But that's quite a interesting range, because there's a lot of applications that whenever people are involved, so that you're working in about 30 meters of water depth, because that's where a lot of infrastructure is. So like harbor environments, coastal environments, that would go up to 30, 40 meters in most cases.
And need to be very precise.
They need to be precise. If you are on deeper water, you need to be just as precise. Then you can use a system that operates on an ROV or AUV, where you simply bring the system lower to the seabed, and then you can still get that precision. So a lot of the offshore activities, they all use ROVs with our equipment, and they would be a couple meters above the seabed, and then they could still achieve that high accuracy that you want.
Interesting. So I know, sonar has been around for a really long time, and there's been, this evolution of sonar over the decades, and there's been a lot of changes. Could you talk a little bit about that, and, and maybe, I guess, a little bit about the future of the technology?
Yeah, sure. I think this is actually quite an interesting time, because if you look at kind of how the sonars have changed over the last 20, 30, 40 years, is that it's very much been a matter of scale, where we, the first multi-beam sonars just had a couple of beams and quite low frequencies, and then as processing power increased and the transducer designs improved, we now have systems that have many beams and also have lots of processing power to create that and to produce kind of the deliverables at the same time. And so it has been very much a matter of scale, but I think we're also coming close to a sort of plateau where we're reaching the limits of physics, and so I think whereas the first it was very much about scalability, I think in the future we start be looking at improving the usability, and like I said before about that things need to become simpler, easier to use. I think that's where the big moonshots are going to be for usability rather than scale. Yeah, let's watch this space and see what happens.
It's really cool technology. I started out earlier talking about, I'm a little bit of a sonar geek because it really is. I mean, I've used it many times and I've trained people on it, and it's got a lot of applications, and it's just really interesting technology, and would be really limited in what we could do, underwater without it. So yeah, it's been a real pleasure talking to you, Pim, and thank you so much for being on Marine Tech Talk and taking the time today to chat about sonar, one of my favorite subjects. And yeah, thank you. Thank you very much.
Yeah, it was very nice. Thanks very much.
Thanks for listening to the Marine Tech Talk podcast. For more information about the line of Teledyne Marine products, you can visit www.teledynemarine.com. If you have any questions or comments about this episode, you can email marinetechtalk@teledyne.com. If you like this podcast, please be sure to subscribe on Apple Podcast or wherever you are listening to the show. That way, you will never miss an episode. Thank you for listening, and we will see you again next time on Teledyne's Marine Tech Talk.